We're going to talk about the special trig limits. These are the two limits that we need to know to be able to finish the proof of the derivative of sine of x. So the first is the limit as x goes to 0 of sine of x over the x. So what do we think that should be? Well, if we look at a graph of sine of x, it looks something like this. And if we remember that we've already calculated the tangent line of sine of x at 0 to be the line y equals x. So what does that mean? That means that near 0, sine of x is approximately the same thing as x. So if we're taking the limit as x goes to 0 and we're dividing sine of x and x, we would think, well, if these things are pretty much the same, you know, we're looking at sine of x divided by x, we're pretty much looking at x over x. And we should guess then that this limit equals 1. Now this is in no way a mathematical proof, but it is a reason for you to think that this limit is 1, and it turns out that it actually is. The other limit that we need is the limit as x goes to 0 of cosine of x minus 1 over x. Now this one we actually can do algebraically. So if we take the top and bottom of this equation and multiply it by the conjugate of cosine of x minus 1, which would be cosine of x plus 1. Remember, conjugate just means that you take the middle sign and you change it. Then we multiply together. We get limit as x goes to 0 of cosine squared of x. And then we're going to have plus cosine and minus cosine, but those are going to cancel. And then minus 1 over x cosine of x plus 1. Now, why did we want to do this? Because remember the Pythagorean identity, sine squared x plus cosine squared x equals 1. So that also means that cosine squared x minus 1 equals negative sine squared x. So we can rewrite our limit as the limit as x goes to 0 of negative sine squared x over x times cosine of x plus 1. Now we look at this and we still are thinking, well, this is giving me 0 over 0. It is. But now we can use the limit that we just convinced ourselves was 1, sine of x over x, as x goes to 0. So we're going to separate the limit we're working on now into two limits. We're going to have sine of x over x as x goes to 0 times negative sine of x over cosine of x plus 1. Now we know from the previous slide that this gives us 1. And this is going to go to sine of 0 is 0 over cosine of 0 is 1 plus 1. So it's 0. So this limit is 1 times 0, which is going to be 0.